Welcome back, Pre-Calc. We're doing 2.2 now, the remainder theorem, which involves polynomials. Now, what I do want you to remind yourself of is there's synthetic division and then there's also long division. I would like you to be able to use both. Most of the problems that we do will involve synthetic, but I'm actually going to do this one, number 3 here, using long division. So as a reminder, and I recognize I do this slightly different than what you may have learned in Algebra 2, is as a reminder, as we set it up, what goes in the box is the opposite of what you're dividing by. And the reason for that is, if you think back to the zero product property, is it's the x equals value goes into that box. And what goes everywhere else is your coefficients. Make sure that you have it with the highest exponent first, and then go over to -2, rewrite it if you have to, and then your next highest exponent, and then the constant is last. So as we're dividing, at least how I have always done it, I just bring the first number down, and then you multiply by what is inside the box. The -3 times 1 is just -3. And then, I didn't write it before because you just bring it down, but you add going down. -2 plus -3 is -5. And then you multiply by what's in the box, which is why we write it this way, and then add straight down is -3, and then multiply by what's in the box, and then adding straight down. So what happens is, we started with a cubic. When you divide by a linear, because it's to the first power, you just remove 1 from your exponent. So it's -3x squared. It's now a quadratic. Minus 5x minus 3. And I always just write plus your remainder. And your remainder is always written as what you divided by, x minus 1. I've also had students that start with, like they put a little box right here to remind themselves that this is the remainder. Remind that you have a remainder. You put this over what you divide by, and then here's your new constant, and then your linear term, and then your quadratic term, your squaring term. Whatever works for you. Yeah. Let's move on to the next one. So again, I'm just changing colors for you. Opposite, and then your highest exponent first. Notice we're missing a cubed term. Well, that just means that you have a 0 in here for synthetic. 0x cubed is right there. 1 for your x squared, minus 3, and then 3. So that's a nice reminder for you in case you've forgotten. I'll just switch back to black. Bring the 3 down, multiply by what's in the box. Adding straight down. Multiply. Adding. Multiply. Adding. And multiply. Let's see, 2 times 30 would be 60. So that must be 58, with a remainder of 61. So it doesn't matter how you think about what your answer is. Just make sure that you get your remainder over what you divided by. By the way, if I ever have a typo, please bring it to my attention. So I tend to make mistakes on things, especially when I'm going fast like this. So synthetic always works. Let me just write it right here. If it's a linear binomial, well, usually a linear is binomial. Linear, I mean to the power of 1, because if you have it squared, it's going to put a little wrench in how to do this. So you would go to long division. But also you want to have a leading coefficient equal to 1 when you do this. So that's why we have an issue with this. Our leading coefficient is not 1. So there is a way around this using synthetic. I just don't want to teach it that way. So we do have a linear, it's to the first power, but it does not have a leading coefficient of 1. So let me remind you on how to do long division. And yes, I know you did this in Algebra 2. So I'm just writing it the way you probably did long division ages ago. And you just ask yourself, well, what times 2x gives you 2x cubed? That would be x squared. So we write that up there. So now you multiply x squared by each piece that you divided by. So x squared times 2x is 2x cubed. And x squared times -1 is negative x squared. Now is the important part. Make sure when you subtract each piece so that this piece should go away, and it does. But x squared plus x squared is 2x squared, and then you bring down your next term. I mean, you could actually bring down all of it if you want, but most people just do one at a time. So 2x times what gives you 2x squared? That would be x. So x times 2x is 2x squared. X times -1 is negative 1x. But again, as you subtract, make sure you subtract every piece because it's like you're distributing. And like I already showed you, the first term should cancel, but negative 13x plus 1x is negative 12x. And then bring this 6 down. And 2x times what gives you negative 12x? That would be negative 6. And now distribute that. Negative 6 times 2 is negative 12x. Negative 6 times -1 is plus 6. And as you subtract each piece, well, this is kind of nice. They both cancel out. Well, that just means you get a remainder of 0. And think back, if you get a remainder of 0, that means that this is a factor. I could talk all day about factors, but I'll spare you. So if you get a remainder of 0, you don't have to write the remainder. If it helps you, you could, but what's 0 divided by anything? It's still 0. So that was a waste of time. You don't have to write it. There you go. So again, pause the video. Make sure you understand before we get into a little bit more complicated stuff. But yeah, this is what we're going to do. So moving down here, we're going to get into the remainder theorem. So what they want you to do first is just to plug in 1 in for all these x's and see what you get. Now this is actually really nice that they chose 1 to begin with, because 1 to any power is just 1. So 1 to any power is 1, but times 2 minus 1 minus 3. So I'm looking at 1 plus 2 is 3, minus 1 is 2, minus 3 is negative 1. So now what they ask you to do, and let me highlight this for you, is notice the similarities between these things. Is this one is x equals 1, and this one is p minus 1. Well, that's the factored form to get to, let me change colors, x equals 1. So what do we put in the box when we do synthetic division? Is we would put 1 in the box, and then let me switch, I don't know, purple sounds good, with your coefficients. So bring your 1 down. I guess I should have circled this answer. That was your answer when we plugged in 1. Multiply, add, multiply, add, multiply, add. What do you notice about your remainder in this problem? Your remainder, I should have wrote out remainder, is equal to the value at that point. So do you think that'll keep happening? Well, let's see. Well, let's try p of 2. Okay, well, 2 cubed is 8 times 2 is 16. Minus 2 minus 3, so that's 14 minus 3 is 11. Again, double check my math. You can never trust me. I do tend to make mistakes. So remember that the divisor, if we look at x minus 2, the divisor is the same thing as x equals 2 right here. So that's what goes in the box. I'm not going to change colors this time. But remember, you need a 0 there for the x squared term. It's missing. So bring the 2 down, multiply, add, multiply, add, multiply, add. Well, it still works. The remainder equaled the value at that point. So go ahead and try the next one. And I'm just going to work through it and see if you get the same thing. Now be careful when you square or take it to the 4th power and negative, it's going to go back to being a positive version. So negative 1 to the 4th power is positive 1, so it stays negative 2. Hope I did that right. And again, it says x plus 1, but we're putting negative 1 in the box. So again, set up your long division. Oh, I didn't mean to change colors. Just bring straight down, multiply, bring straight down, multiply, adding straight down, multiply, add straight down, multiply, and add straight down. Alright, this actually took me 2 tries to do, which is why I was kind of quiet for a while. But the fact is, the remainder theorem, which we're about to get to, is that the value of the point should be equal to the remainder of the divisor. And this is a huge time saver if you utilize this properly to check your work. So pause if you need to see any more work. We're going to move on. So again, I don't really like that this person set it up this way. But if you did this using long division, you can also check the remainder is also the same. Now, as you're looking at this, the correlation is still the same, that this is your x value is negative 3/2. And if you solve for x in this problem, it is negative 3/2. I just don't want to teach you how to do synthetic division when a leading coefficient is not 1. A leading coefficient is not 1. So I'd rather see you do long division on this type of problem. Plus it's good practice, so don't be mad about that. So 2x times x cubed gives you 2x to the 4th. As you multiply it, you would get 2x to the 4th plus 3x cubed. Remember, you're distributing this value to each of these. Subtract them all off. So that cancels. That's now 4x cubed plus bring down. So 2x times 2x squared gives you 4x cubed. 2 times 3 is 6. X squared. Subtract them each off. So we're at negative 2x squared. I'm going to bring that minus 7x down. So this time it's a negative x to distribute to each of those. Minus 3x as you subtract each piece. These cancel. I didn't write that. Those cancel. But negative 7 plus 4 is negative 4. I said that wrong. Negative 7 plus 3 is negative 4x. Bring that 6 down. 2 times negative 2 gives you negative 4. And as you subtract, both of those cancel. So your remainder is 0. Remainder is 0. So what does that mean? Is if you plugged in p of negative 3/2 into this problem, you would have gotten 0. Now, which one's a little bit easier? It's kind of tough to tell. So I would encourage you to pause this video. I'm going to pull up the answer key to have you write down the remainder theorem. So I'm going to do that in the very next second. So there's the very last example as well. P of 2 equals negative 11 if you plug it in. And if you show the analytical work with your remainder, you see that the remainder is equal to the value at that point. So hopefully if you did not get it, what should you have noticed in the previous examples is the remainder of each synthetic division is the same as the y value of the function that corresponds to the x value that makes the divisor equal to 0. We showed all of that work. All right. And again, these are your notes, whatever you need to write down. But there will for sure be a problem at some point on a test that asks you to use the remainder theorem. Or what's the relationship? If I ask you to divide by x minus a, what does that mean for f of a? And I'm about to be done with the video, so pause it.